Today our objective is to be able to simplify and compute operations with radicals. This is a review lesson of what we've done the past few days over simplifying radical expressions. If you look at number 1, we have radical 12 times radical 18. There are two ways to do this problem. You could go ahead and take 12 times 18 and see what number that is and try to simplify. Or what I'm noticing is 12 has a perfect square number of 4. So what I'm going to do is I'm going to break down the 12 into radical 4 times radical 3. And I'm also noticing that 18 has a perfect square number of 9. So I'm going to break that down into square root of 9 times square root of 2. If I take the square root of 4, I get 2. So this is 2 radical 3. Square root of 9 is 3. This is 3 radical 2. Now I can multiply these. 2 times 3 is 6. 3 times 2 is 6. There are no perfect square numbers that go into 6. So my final answer is 6 radical 6. Now I could have done it a different way. I could have go ahead and take 12 times 18. If I do it that way, I will have the square root of 216. And then I would have to try to find what perfect square number goes into 216. Well, I'm thinking 36 does, because 36 times 6 is the square root, or is 216. So I could break this down into radical 36 times radical 6. The square root of 36 is 6, then I will get 6 radical 6. So either way, I'm going to get my final answer of 6 radical 6. On number 2, when I multiply, what I'm going to do is multiply what's not under the radical, the 4 times 5, to get 20. Then I'm going to multiply 10 times 6 together because they are under the radical to get 60. X to the 4 times x to the second would be x to the 6th. Y times y to the second would be y to the third. Now I've got to ask myself, are there any perfect square numbers that go into 60? Yes, 4 does. So I can say this is 20. Okay, I still have my 20 out in front, but 60 is the same as the square root of 4 times the square root of 15. Can I take the square root of x to the 6th? Yes. Square root of x to the 6th would be x to the third. Can I take the square root of y to the third? I can take the square root of y to the second. The square root of y to the second is y, and then I'll have one y left over that I'll put under the radical sign. Now I need to simplify a little further because the square root of 4 equals 2. So what I'm going to do is take this 2 times 20 to get 40. Then I'll have x to the third y. Looking over here under the radical, I still have a 15 and a y. And just double checking, are there any perfect square numbers that go into 15? 4, 9, 16, no. So this is simplified. On number 3, there are a couple of ways you could do this problem. Notice that there is a radical sign in the denominator. So you could rationalize the denominator by multiplying by the square root of 80 y to the third over square root of 80 y to the third. Those numbers are going to get really big, but I could do it that way. I could go radical and then 80 y to the third over radical 80 y to the third, because I'm trying to get rid of the radical in the denominator. When I do that, I'll get 6 radical, let's see, 8 times 80 is 640, and then I'll have y to the third. In the denominator, I'll have the square root of 80 times 80 is 6,400. Y to the third times y to the third is y to the 6th. Then I could take the square root of 6,400. Well, the square root of 64 is 8, so this would be 80. The square root of y to the 6th would be y to the third. Then I'd have to try to simplify the square root of 640 y to the third. So I know this is the same as the square root of 64 times the square root of 10. And then I have the square root of y to the third. So the square root of 64 is 8. I'm going to take 6 times 8 to get 48. I'll have radical 10. I can take the square root of y to the second. So I'll take the square root of y to the second, which would be y. But since I had a y to the third, I'll have 1y left over. And then in the denominator, I have 80y to the third. Now I could simplify further because 8 goes into 48 6 times. 8 goes into 10, or 80 10 times. And then I could even say, hey, 2 goes into 6 3. 2 goes into 10 5. And I could even cancel a y here with one of these y's to get y to the second. I cannot cancel this y with this y to the second because the numerator has the y under the radical. The denominator does not. So if I simplify my answer would be 3. Then I would have radical 10y over 5y to the second. Now, there was an easier way to do this. Since 8 and radical 80 are both under square root signs, you can cancel them. So you can always cancel if they're not under a radical or they're both under a radical. So since 8 is under a radical sign, 80 is under a radical, you could say 8 goes into 8 once, 8 goes into 80 10. And then you can have the square root of 1 here, which is just 1. So if I do it that way, I'll just have a 6 times 1, 6. Then I'll have radical 10y to the third. Then I could rationalize the denominator by multiplying by radical 10y to the third over radical 10y to the third. My writing's getting a little sloppy there, so let me fix this. Okay, so when I do that, I'm going to have 6 radical 10y to the third over the square root of 10 times 10 is 100. Y to the third times y to the third is y to the 6. Well, now my denominator is a perfect square. I could take the square root of 100 and get 10, the square root of y to the 6 to get y to the third. I also have a y to the third under the radical here, so I could simplify that by thinking of y to the second. The square root of y to the second is just y, so I'd have 6y, and then I would have a y left over, so under the radical I'd have 10y. Do you think I could simplify further? Yes, I can, because 6 has a common factor and 10 have a common factor of 2. So 6 divided by 2 is 3. 10 divided by 2 is 5. I can also cancel a y, and then I'll have y to the second left in the denominator. So my answer would be 3 radical 10y all over 5y to the second, which is the same answer that I got the first time. Okay, now we're ready for number 4. So I'm noticing on number 4 that 48 and 3 are both under the radical. So I could simplify them and say 3 goes into 3 once, 3 goes into 48, 16, and then I'll have the square root of 16 over the square root of 1t, which is really the square root of t. But the square root of 16 is 4, so I'm going to have 4 over radical t. But I still have a radical in the denominator, and in order to simplify, I cannot have a radical in the denominator. So I'm going to multiply by the square root of t over the square root of t, which will give me 4 radical t over the square root of t squared, because t times t here is t squared. The square root of t squared is just a t, and then I have 4 radical t. Do you think I could cancel this t with this t? No, I can't, because this one's under a radical and this one's not. So this would be my simplified answer. Okay, looking at number 5, I'm going to use the distributive property. So remember, when we use the distributive property, we take what's in front of the parentheses and multiply by what is in the parentheses. I'm going to take 4 times 3 to get 12. Then I'm going to take square root of 5 times square root of 10 to get square root of 50. Then I'm going to take 4 radical 5 times negative 2 radical 5. So that would be negative 8 radical 25. I have to make sure I simplify. So 25 goes into 50. This would be the square root of 25 times the square root of 2. And also, 25 is a perfect square, so square root of 25 would be 5. Here, the square root of 25 is 5. So I could take the 12 times 5 and get 60 radical 2. 8 times 5, 40. Can we take 60 radical 2 minus 40? No. This first term has a radical 2, the second one does not. So this is my final answer. Looking at number 6, I have this to the second power. So I'm taking a binomial times a binomial. I'm going to have 6 radical 2 minus 4 radical 7 times 6 radical 2 minus 4 radical 7. So remember, when you multiply a binomial times a binomial, you need to use FOIL. So if I multiply my first term, 6 radical 2 times 6 radical 2, I'll get 36 radical 4. Outside would be the negative 4 radical 7 times the 6 radical 2. So that would be a negative 24 radical 14. Inside would be a negative 4 radical 7 times a 6 radical 2. So that would also be a negative 24 radical 14. And the last would be a negative 4 radical 7 times a negative 4 radical 7. So that would be a positive 16 radical 49. Okay, now I need to simplify. So I know the square root of 4 is 2, so this is 36 times 2, which is 72. In the middle, the outside and inside terms here are like terms because they have like radicands. They're both square root of 14. So I can combine the 24, the negative 24 and negative 24 to get negative 48 radical 14. And then at the end, my last terms gave me 16, but I have the square root of 49. So the square root of 49 is 7. So what I'm going to do is take 16 times 7, and that would be 112. Okay. I'm looking to see if I can simplify any further, which I have a constant here, 72, and a constant here, 112. So I can add that together to get 184 minus 48 radical 14. I'm looking to see if I can simplify any further. There are no perfect square numbers that go to 14. I can't subtract these because the first term is not like the second term. It doesn't have a radical 14. So that would be my simplified answer. Okay, on number 7, I need to simplify by multiplying by the conjugate. Because I have radicals in the denominator, I'm going to multiply by the conjugate of radical 3 minus radical 11, which would be a radical 3 plus radical 11. So I'm multiplying by radical 3 plus radical 11 over radical 3 plus radical 11. When I do this in the numerator, I'll have a 12 radical 3 plus a 12 radical 11 if I use the distributive property. In the denominator, what I'm really doing here is using FOIL. So when I do FOIL here to multiply these two binomials, the first terms will give me radical 9. The outside will give me plus radical 33. The inside will give me minus radical 33. The last would be minus radical 11 times positive radical 11, which would be minus square root of 121. Well, the middle two terms are going to cancel out, and then I'm going to have a radical 9, which is 3, minus the square root of 121, which is 11. 3 minus 11 will give me negative 8. So now I no longer have radicals in the denominator. But I could simplify further because 4 goes into 12 and 4 goes into 8. So I could have left my numerator like this, 12 radical 3 plus radical 11 all over negative 8. I didn't have to use the distributive property, so let me fix this here. If I'm not using the distributive property, I'll have radical 3 plus radical 11 times 12. But notice I can cancel 12 and 8 because 4 goes into both of them. So 4 goes into 12, 3. 4 goes into 8, 2. And think about this. I have a positive divided by a negative. So a positive divided by a negative just means my answer is going to be negative. I'm going to have 3. And it really doesn't matter whether you use the distributive property or you just leave the radical 3 plus radical 11 in the numerator in parentheses. I know I'm having a little trouble here, so let me fix this. I'm trying to write radical 3 plus radical 11. There we go. And then the denominator was a 2. Okay, we have 2 more problems to go. If you look at number 8, it says 5 radical 200 minus 2 radical 32, and we need to simplify. So I'm looking at this. I know I can't subtract them because the radicands are different, but 100 goes into 200, so I could simplify this to 5 radical 100 times radical 2. And then I'm also noticing 16 goes into 32, so I could say this is the square root of 16 times the square root of 2. The square root of 100 is 10. 5 times 10 is 50, so I'll have 50 radical 2. Square root of 16 is 4, so 2 times 4 is 8 radical 2. Now I can subtract these because the radicands are both 2's. So 50 radical 2 minus 8 radical 2 would be 42 radical 2. Okay, our last review problem. The square root of 162, d to the 5th, e to the 8th, f to the 9th. First, I'm going to look at 162 and see if there's a perfect square number that goes into 162. Well, 81 does, because if I take 81 times 2, I'll get 162. And I take the square root of d to the 5th. No, but I could take the square root of d to the 4th. The square root of d to the 4th would be d to the 2nd, and I would have a d left under the radical. I can take the square root of e to the 8th. The square root of e to the 8th would be e to the 4th. Can I take the square root of f to the 9th? No, because 9 is odd. So we could take the square root of f to the 8th. The square root of f to the 8th would be f to the 4th, and then I would have 1f left over. So if I simplify, the square root of 81 is 9. Then I'll have d to the 2nd, e to the 4th, f to the 4th, and under the radical I'm going to have a 2df. Alright, so our objective today was be able to simplify radicals. Your assignment is in IXL. It is skill EE8. Make sure you go to algebra and not 7th grade. Your job is to master it by getting a score of 100. So IXL skill EE8 in algebra.